Hello everybody, we are going to start the first webinar of the last day of the gvSIG festival. It will be about monitoring global urban expansion, assessing the quality of urban layouts. It will be given by Manuel Madrid, who is surveying engineer and master in validation, cadastral and territorial information systems. He's also a GIS consultant at gvSIG Association. Firstly, I want to tell you about the chat. If you have any question about this presentation, you can ask it at the chat at the right side. If you have any problem with the audio or video, you also can tell us at the chat. And if you don't see the slides very clear, you have a YouTube link at the right side at the bottom, where you can change resolution to 720. So, Manuel, whenever you want, you can start.
Thank you, Mario. Hi, everyone. My name is Manuel Madrid. I'm a GIS consultant at the gvSIG Association, and I'm talking about a methodology that has been developed by the gvSIG Association and the New York University for assessing the quality of urban layouts using high-resolution imagery and GIS. I'm going to share my screen. Okay. Yeah, I think you now are seeing the presentation. So the first part of the presentation will be an introduction to explain the purpose of the methodology. And in the second part, I will talk about the methodology itself. Urban expansion is happening, is a fact. Cities are growing very fast, especially those of the less developed countries. In this example, you can see two pictures of Accra, the capital of Ghana, taken at two different times, 1985 and 2000. So we can see the huge expansion Accra suffered in that period. Estimates say that within the following 30 years, most of these cities will double its population and triple its area. We also know that the shape of urban layouts has a direct relationship with the economic, social, and cultural development of cities. Factors like the proportion of public spaces, the proportion of street space, or the size of blocks have a direct impact on mobility and on people interaction. According to UN Habitat recommendations for sustainable urban planning, cities should aim to have at least a 30% of land allocated to streets, at least a street density of 18 kilometers per square kilometer, and between 100 and 140 intersections per square kilometer. Parameters and others are easily measurable on vector geospatial data, so we are able to analyze urban layouts from an empirical point of view and then know how far that cities are from accomplishing the standards. Identifying the most problematic cities would let them develop adequate urban planning policies in advance of expansion. This is the objective of an ambitious research project called Monitoring Global Urban Expansion, launched by the New York University in partnership with UN Habitat and the Lincoln Institute of Land Policy. It has both a quantitative and a qualitative perspective, because it's not only about quantifying the expansion, but also about how the expansion took place. It includes individual analysis of different expansion periods, which is a very interesting point, but probably the most interesting point is that it has a global scope. So the study was made on 200 cities, which is an stratified sample of the universe of more than 4,000 cities that had more than 100,000 people in 2010. So the findings of the research will be extrapolated to the universe of cities, giving us a global knowledge about urban expansion. Phase 2 of this project is about assessing the quality of urban layouts by measuring the following features: land use areas and shares, proportion of street space, street widths, block size, intersection density, walkability, plot dimensions, access to arterial roads. All these indicators can be obtained from vector data, so we developed a methodology to calculate them for the 200 cities. So the methodology has two parts. The first part is the generation of the necessary vector data, and the second is the geoprocessing of that data in order to get the matrix. The vector data was digitized on high-resolution imagery, such as Bing or Mapbox, using JOSM, which is an open source software from the project OpenStreetMap. You probably know this tool. It's wonderful. For the geoprocessing, we used some Python scripts. Initially, we considered to use OpenStreetMap data, but most of the indicators could not be calculated from it. So we decided to generate new data. Obviously, to digitize the entire cities was not affordable. We sampled the study areas using a Halton sequence, which generates a quasi-random set of points. The main advantage of this kind of sequence is that it has a much better spatial coverage, as you can see in the picture, than a truly random sequence. And still it is random, which is very important in order to assure the representativeness of the sample. We used two different densities of point depending on the size of the study area in order to provide a minimum number of samples. In this example, you can see in this picture is from the city of Tokyo. In the very center of the city, we used a higher density of points than in the rest of the areas because it was smaller. Around each of these points, we drew a circle with an area of 10 hectares, 0.1 square kilometers, and we focused the analysis on these circles that we call locales. In this picture, we can see that the locales are truly random and spatially distributed. Before starting the digitization, we established a land use classification including the following categories. The first category was open space, which mainly refers to unbuilt areas such as open countryside, forests, crop fields, parks, water bodies, etc. Non-residential category includes built-up areas that are not for residential use. For example, industrial parks, railway stations and tracks, bus terminals, airports, port facilities, schools, universities, shopping centers, etc. Residential areas were classified depending on the stage in their evolution, considering the following factors: the homogeneity of structures, especially the plots and the blocks, the regularity of the street network, and the quality of public services visible in the imagery, usually limited to paved or unpaved roads. Within the residential categories, we can find atomistic or not laid out, which is the one that we can see in this picture. It refers to areas that were not planned nor subdivided before the residential development took place. So typically we can identify these areas because the lack of the street network regularity or pattern. Informal subdivisions are areas in which land has been subdivided for urban use, but lacking visible evidence of legal formalities such as paved streets, street lights, or sidewalks. Formal layouts are similar to informal layouts, but exhibit a higher level of infrastructure, especially or specifically, all the roads must be paved. And finally, we have housing projects that are areas where the structures are homogeneous because they were built of the same plan. Can include from apartment towers to suburban tract housing. So once we have cleared all the land use categories, we started the digitization tasks. For each locale in the sequence, we digitized the following elements or layers. First layer was the local boundaries, which are the circles itself in most of the cases. Only in case of an overlapping between two circles, we modified the boundary of the second circle. But in most of the cases, this layer contains just the circle boundaries. From this layer, we get the total area of the sample. The second element we digitized was the block boundaries, separating the block space from the street space by identifying the right-of-way. All the blocks were tagged according to their land use, and those blocks containing more than one land use were split. From these polygons, we were able to measure all the features related with land uses, street space, and street widths. In order to capture the typical plot size within residential formal and informal land subdivisions, we measured, where possible, plots widths and depths. And finally, the last layer we used was the road medians. We digitized the road medians around all the blocks that intersect or that are completely included in the locale in order to measure block size, connectivity, and walkability features. So in order to assure the representativeness of the sample, we follow this workflow. We started with an initial set of 40 locales. We digitized these 40 locales, and then we calculated the metrics, the average values, and the degree of confidence by a statistical formula. And so until a high degree of confidence was reached, we kept digitizing locales. We kept adding locales to the digitization task. And then once the high degree of confidence was reached, we stopped digitizing. The final part of the digitization tasks was to arterial road grid. So arterial roads play an important role within the cities as they allocate public transportation and supply networks. So in order to measure or to estimate the access to arterial roads, we carried out the digitization of all the arterial roads in each city. We subdivided the study area using a 2 kilometer per 2 kilometer grid in order to facilitate the discovering and to avoid missing areas. And the result is what you can see in this picture from the city of Bangkok. It's the arterial road network of the city. So we basically identified that accomplish two requirements. A capacity requirement: streets should have more than 18 meters wide, or should be more than 18 meters wide, and the connectivity requirement. So all the streets should be connected each other. So as mentioned, all the metrics were calculated by processing the data sets obtained in the digitization with several Python scripts. Some initial findings were presented on early April in Barcelona at Habitat Free thematic meeting on public spaces. Figures showed a gradual decrease of the quality of urban layouts over the last 30 years, particularly a decline of planned areas and an increase of block size. These are just the initial findings. Now we are still calculating, finishing the digitization tasks and calculating the indicators. And we hope that final findings will be presented in October at Habitat 3, which is the UN conference, the United Nations Conference on Housing, held every 20 years. So just for finishing, say that we really hope that the findings will be useful for decision makers in order to make cities more livable. And that's all. Thank you so much for your attention.
Thank you, Manuel. Thank you very much for your presentation. There's a question about this, about your presentation. Are you applying this methodology in other projects?
Yes. So we are also using this methodology in other projects for UN Habitat. So UN Habitat, as you may know, is the United Nations Agency for Human Settlements. And they are carrying out similar initiatives to assess the shape of the cities and the shape of the urban layouts. And there is an initiative called City Prosperity Initiative that includes also the calculation of this kind of indicators. And we are carrying out this work for UN Habitat that includes the calculation of similar indicators following the same methodology, or very, very similar methodology.
Okay, thank you very much. So if there is any other questions, thank you very much for your clear presentation. And thank you to all the participants too. And we invite you to the next webinar that it will be the last one of the gvSIG festival. And there's another question. And you read it, yes.
Was decline in planned layouts due to lack of GIS technology in country or province? No, I don't think so. So it is very soon to get the whole view of the figures, but I don't think it is because a lack of GIS technology. It is more likable that that is because the is the trend of urbanization now, and the speed these cities are growing. So in most of the cases, don't let the the city governors or governance um, plan this. So these cities are growing uh, on not planned areas because really the governance of the cities are not prepared for this expansion. So the people is taking the land without a planning. So in general, I think this is why the decline of um, land areas in expansion areas. So it is a decline along the last 30 years. So means that it's in the most recent periods that is happening this lack of plan layouts. So I'm not an expert on urban planning, but and maybe we should wait for the final findings of the study. But my guess is that this is because the speed. It is because the speed of the occupation. The occupation is taking place in a very fast way. So the governments are not really planning this expansion. This is just my guess, but I'm not sure about this.
Okay, thank you very much. And thank you very much, Manuel, and all the participants for following this webinar. So we finish this webinar at this point, and we invite you to the next webinar in half an hour, more or less. Thank you very much.
Thank you to you all. Bye.
Bye.